Hello guys, I welcome you back to another episode of Crash Technical Drawing for SS1 to 3. And in this episode we'll be trashing out a question where we are given the front and end elevation of a cylinder. We have to draw an auxiliary plan looking in the direction of an arrow. So basically this is the line parallel to the arrow. So I'll just draw it so that it can be easier for us to understand. So this is how the arrow looks. The arrow in this direction, okay. So I'm drawing an arrow, the line parallel to the arrow. Swap the arrow here. So if you are given an arrow, you just put your ruler on the arrow and draw a line parallel to the arrow. So first of all, let's radiate lines from every point, from every vertex of this drawing, as we've always been doing. That's to show that each of them is going to be in the direction of the arrow. So at B we'll radiate a line. So I'll also extend the line later on, but I'm radiating them on ground. So I'll also radiate this one. I'll take the other side now because it can't pass this place. So we have this one. This one here. So we have this one here. Good. Then let's draw a line parallel to it here. There we go. Cool. So finally we've radiated lines from all the points. Now the next step I want us to do is we'll divide the vertical diameter of the end elevation into an even number of parts. So now we have the diameter of the end elevation into an even number of parts. So that would be the vertical diameter though. Let's divide the vertical diameter of the end elevation, because when we are drawing auxiliary elevation we need the vertical distances. So I'm drawing the auxiliary plan anyway. So we need to divide the vertical diameter. So this is the XX, the vertical diameter of the end elevation. So remember, this is the front elevation and this is the end elevation. So divide this into an even number of equal parts and project horizontal lines to the front elevation. So let's divide the lines and project them to the front elevation. So yeah, I'll just arbitrarily start from anywhere, because this is 3 centimeter in diameter. So that means I could divide it into a group of let's say 3 centimeters distances. So I'll divide it now. So I've done the division process. Now the next step is to radiate lines from these end elevation to the front elevation. So that's what I'll do now. Now this is the procedure. Just take some lines and radiate them to the front elevation. Start from here. So I want to radiate from the very end so that our lines will pass thoroughly through. So in order not to do this twice, I could make use of a big set square, but I don't want to make too much effort right now, so I'll use them. This is the middle division. I also have the next division. So this is division into an even number of parts. There we go. So then I will also transfer this to the ends of the front elevation, so to the opposite ends. So you can see that I'm doing just that. So then I've divided it and I've transferred them to the opposite ends. Now the next step is to project lines from the points on A, B, and C parallel to the arrow. So I'll project lines parallel to the auxiliary elevation, to the auxiliary plan, the plane of the auxiliary plan. So that's simple. Now this is the process of projecting the lines. I'm doing that with the first, project the second, project the third, project the fourth, project the fifth from the center. So I'll keep doing this till I get to the top. So I advise you make use of a long ruler for this, so that to minimize the number of times you have to extend these lines. But because I have a long ruler, but it's not within my reach right now. So though I must say that it's actually quite stressful to do this work without a long ruler. So by next video I'll make sure it's close by. So just make use of construction lines to project this. So finally we also have the last one, so extended. Now here comes the extension. So this could have been avoided with if I had made it of a long ruler, and it reduces the accuracy of my work. But this work doesn't require much accuracy. That's not to say you can make mistakes. That's not to say you should make mistakes and ignore them. But technical drawing is a type of subject that it requires some level of creativity. So, and creativity comes with some assumptions. So I'm assuming that I'm perfect enough, whereas I know that that's not the case. So these extensions, they are going to represent the points for these projections. You can, if you could guess properly, you know that these extensions, they are going to form a curve, because whenever you have a cylinder viewed from an inclined plane or direction, you know that those ends will be elliptical in shape. So these lines, they will form an ellipse. So I haven't drawn it finished, but I can predict how it will look. Now the next step is for us to at any convenient distance draw lines 0, 0 perpendicular to the arrow. So let's start from this. Let's draw at this distance. So at this convenient distance, I'll draw lines perpendicular to these arrows. So that's here. Okay, I guess I should increase it here. Something like here. Let's use this instead. So next we have here. So next things I will be so I also need to push it a little bit backwards, because I guess there's not enough space for this. So I guess this can be pushed here. So I hope this is visible. So as if the quality of this video is good enough. So the next step is I'll mark the end elevation width and transfer them to the plan. So this end elevation width, they are basically the projections of these divisions on the vertical plane. So all I need to do is I'll just take my set square and project each of them to the vertical plane. So I'll get the end elevation width. So from this one we have it upward, and from the second one it's here, the third is here, the fourth right here, the fifth is here, we have the top here. Then going to the other end, we have this here, we have this here, this, and then this. So this will be 1, 2, 3, 4, 5. Will be 1, 2. So these are 2 lines in 1, 3, 4, 5. So good. Next, let's draw a vertical line, horizontal line to transcend them. So let's call this 0. These are 0. So first of all, we need to transfer the heights on the. So we transfer the heights. So transferring the heights, we have them here. So the height, this is the center line, so we can just use that same radius. Then we'll draw a line parallel to this baseline from here. This is the parallel line. Then here also. So good. So finally, we also need to transfer this width from this center line 0. So at this center line we have the next one. divisions. You can also just assume that they are symmetrical. So I'll just be transferring them on opposite ends. What I mean is I'll cut on this side and then I'll cut on opposite side. Just assume that because this circle is kind of symmetrical in both sides. Then for the next one, just cut on both sides. The left and then the right. Then the next one, also cut on both sides. That's for the third. See it here. Third cut on both sides. Third. Yeah. Then I have the fourth in between. The fourth here. It's just between them. So the fifth also coincides with the so we don't need to draw it again. The fifth is the ends. So these are the ends here. So we don't need to draw them again. The next thing is to just draw lines parallel to the ends. And then we can now trace our curve and draw the auxiliary plan from there. These are almost meeting. Very, very close to each other. So I can now turn it here. So I'm drawing parallel lines here. So that's what I did. So it intersects here. So the next step is for me to draw the part of the curve. So now the curve spans from here to here. The curve on this side spans from here to here. So I'll draw a curve here. And then I'll also draw a curve spanning from here, this point to this top here. So basically, I need the intersections 1, 2, so to 5, 1, 2, 3, 4, and then 5. That's the midpoint here to be the fifth. Good. Midpoint here will be the fifth, yes. So then the top here also have 1, 2, 3, 4, and then 5. 4, 3, 2, 1, 1, 2, 3, 4, 5. So now this will be the curve. Then for the top too, 1, 2, 3, 5, 4, 3, 2, 1, 2, 1, 2, 3, 4, 5, 4, 3, 2. So we have this point. So when we just trace a straight line through this point, we could get our curve, and then we can now follow the path of the French curve. So as I mentioned earlier, this will be a curve, and you can see that it's actually a curve. So because this is a cylinder. So I'm drawing a French line through so as to have a guidance for which points I'm going to draw. So then you can decide to trace in with your hand. That's if the curve is too tiny to use a French curve. That's what I'll do here to save time. I'll make it of my hand. But you should also make it as good practice to always make use of your French curve. So this is similar to how you draw if you're using a French curve. You draw it in beats. So that's how the top curve. The top. And this side. And this side. So I'm drawing the side with a lot of bends first. But those are places that really matter the most. So then this side. And this side. So you should only do this in freehand sketching. But if your curve is too small, or if you don't have a French curve, you could do this. So some of them are hidden, but I didn't bother to, because for example this bottom is also hidden. It's beyond the view. You should use dotted lines for that. So this bottom is hidden, but to save time I've drawn it. So that's basically it. And finally, this is the auxiliary plan. Looking in this direction, this is the auxiliary plan of the cylinder. Thanks for watching.